Welcome everyone. In this video, we will explore the topic reducing project duration of the subject project management. First of all, let's find out why reducing project duration is important in project management. There are three main benefits taking out from reducing a project duration. Time to market advantage means launching early helps companies reach customers before competitors. Delays can lead to market share loss as rivals introduce similar products first. Despite higher costs, many businesses invest in speeding up projects to stay ahead. Next, unforeseen delays from unexpected issues like weather or equipment failure can delay projects. In these cases, companies need to find ways to recover lost time by speeding up remaining tasks. Another side benefit of reducing the duration is decreasing the overhead expenses, for example, feeding the workers. Now, let's dive into the case of building Ventura Baseball Stadium in Part A. Previously, we received a project completing constructing a 47,000-seat baseball stadium by the start of the 2022 season. Firstly, as soon as receiving the table demonstrating the activities network made from the work breakdown structure, we need to draw a network, which is a planning tool to describe the logical sequences and interdependencies of project activities to be completed. We then use the Aeon network to illustrate the dependencies. In our network, it's easy to notice merge activity having more than one preceding activity. Among these merge activities, we focus on activity 20 for its potential future benefits to our process. Next, it's important to identify the critical path as it is the longest path that determines the project's overall duration. In our case, there are two critical paths in the project, which are identical except for a single difference. Everything was on track, but then we had that accident.
During the lower bowl concrete pool activity, 2 workers were seriously injured and we lost 4 weeks right there. We started with a 6-week buffer before the deadline April 3, but now it's just down to 2 weeks. With a year of work over left, a $500,000 penalty of dollars will kick in if we miss the deadline, and now we have to choose the best approach for our project.
And here are the options. Now, how can a project's duration be reduced significantly? Here are several approaches. First, start to start. A start-to-start lag is a scheduling relationship where a successor activity can begin a specified amount of time after the predecessor activity starts. This relationship allows two tasks to overlap partially rather than waiting for the first task to finish before starting the next. Second, assign overtime. Scheduling overtime refers to increasing work hours beyond the standard schedule to speed up project completion without hiring additional staff. It can improve efficiency and reduce coordination costs. Now we need to analyze the mentioned options. Initially, we need to determine whether an activity is on the critical path because only those directly impact the project's overall duration. In this case, option B, option C, and option D are not on the critical path. That means they won't actually help shorten the total project timeline. Regarding options A and E, they are both on the critical path. For option A, cutting the seed installation time from 140 to 120 days will speed up subsequent tasks, bringing activity 15 down to 645 days. For option E, introducing a 100-day start-to-start lag for seed installation allows it to begin on day 400 instead of 420, which in turn shortens the next activity by 20 days. However, since the final inspection depends on tasks like roof installation at day 660, the total project duration is only reduced by 5 days. With this reduction, a new critical path emerges, now including the roof installation. To optimize the reduction further, we should focus on options that shorten activities on this new critical path, which only option C does. Now, we need to combine option C with either option A or option E to achieve the best outcome. To choose the best approach alongside option C, we need to consider resource constraints. While option A can help speed up the project, it comes with major risks. First, overtime pay is costly, often 1.5 to 2 times the regular rate. Second, pushing workers too hard can lead to burnout, stress, and even higher turnover. And finally, overtime can cause fatigue, causing efficiency to drop. So we need to consider the risks carefully. Yet, start-to-start lag of option E does not cause such an impact, in which it only starts sooner than expected. Clearly, the advantage of start-to-start lag has outweighed the assigning overtime options 1. Therefore, we reject option A. Option C and E will optimize the reduction of a total 15 days. With this solution, it helps the project manager reduce time, recover buffer time and avoid penalties from client. To conclude, here are a few key takeaways. Make sure you will always prioritize activities on the critical path when seeking to reduce project duration. Secondly, as a project manager, we should not base only on the theory, only reducing the critical path. Indeed, we need to ensure that there aren't any other paths slowing overall project duration. Finally, while shortening a project timeline can help avoid penalties and maintain a competitive edge, it often involves higher costs, worker burnout, and risks to quality. Therefore, you should choose the right method requires balancing speed, cost, and sustainability.